Hello dear students, welcome to the lecture 1 of Introduction to Programming 2. We are going to see this course with C#, so therefore you have to have basic knowledge about programming with C#. As for the course, I will be using Visual Studio Community Edition latest version. So let's start with creating a new project. Meanwhile, I will also compose our folder. Okay, 2001. Okay. Alright, so we will be using VPF.NET, console.NET. You see VPF.NET is actually VPF.NET Core, but it is now named as VPF.NET, and the classical .NET is named as .NET Framework. As for developing applications, there isn't much differences. However, .NET Core, now named as .NET, is newer version. It will be used from now on. It will be developed further. It is the newest technology. It is better. So let's start with composing our first application. Okay, we have selected our folder and I am going to name it as lecture 1. Okay, now composing the project. It is the VPF.NET, previously known as .NET Core. So don't get confused. If you also install the newest Microsoft Visual Studio Community Edition and update it to the latest version, you will also see the naming that as well. Okay, now this is building our application. As for the first lecture, we will start with some remembering of the previous semester. So, how we were able to write methods? First, we defined the return type of the method. It can be void or it can be any parameter. So this will be a void method. Before it, we can define it is static or not. It is static or instance method. So let's write several methods and see all of them. Then after we define the return type, we write the name of the method, such as first, or let's name it as method 1. Then we write the constructor of the method, and here we define the input parameters. It is also defining the signature of the method, such as int param1, let's say double param2. Then we open and close curly brackets like this. And one more thing there is, it is private or public or protected. So this is private static method. Private means that it can be only accessed by the methods under same parent class. So what is the parent class of this method? It is this one. It is the main window class, which is inheriting from window class. So private means that it can be only accessed by the methods under same parent class. So let's define another method. This time let's make it protected method 2. So you see, when I define it like this, it's throwing me an error because same name method exists with same signature. Okay. However, if I add here something else, it would work, but don't get confused right now. So we will see about method 6 later. Okay, so let's call this as method 2. So protected means can only be accessed from within the same parent class here, main window, and any object that inherits of the. Okay, so when we come to part inheritance, we will see that. So if I compose another class which inherits main window, I can access the protected method. I can access the public method, but I cannot access private method. Private method can only be accessed within the same parent class. And then we have public. Okay. So when I make it like this, now I have to have an instance of this method. How can I have instance of a method? You can have instance of a method by composing an object from its parent class. Okay, so let's say I have another class here. I will edit. Okay, let's name it as instance example. Okay, now I can access the static and public methods of main window. Let me show you. Make it private. Let's make this return type heading. So this will return an integer value. So 11. Okay. From main window, I can access method 3. Okay. Why only method 3? Because method 3 is static and public. Therefore, I can access it like this. However, I cannot access the other methods. This is method 4 is also public, but I am not able to access it. Do you know why? By the way, method 3 is taking two parameters, so therefore I will give them 0 and 0. This Okay, so if I want to access, by the way, this one also has to return something, so it will return 0 in this case. If I want to access method 4, what do I need to do? To be able to access method 4, I have to define an instance of main window like this. My another window equal to new main window. Now I have an instance of main window class. You have to have instances of non-static classes methods to be able to use them. Okay. Now I can access method 4 of main window class. Okay, to be able to understand this, you should practice. So this is the what is about static and non-static. To use non-static methods, you have to have instance of the class that has that method. Okay, or same rule applies to methods, classes, and other objects. So here, basically, we have created an object of main window class. We have composed an object of main window class, and then we can access the non-static methods. However, they have to be public non-static methods of that class as well. When we check, you see method 3 is not available because method 3 is not instance having method. It is a static, therefore I cannot call method 3 of this instance. However, I can call it directly as main window class. Like here, let me show you. Like here, even though main window is not a static class, the .NET handles that part and make its static methods available to us. Okay. This is a good thing. Now we have remembered what are public, protected, private, what are static and not, and what is void. Return type having methods such as it can return anything, any class. Let me show you an example. So I will define a class here. Let's name it class car. So class car is by default private. These methods now can return car type. Okay, so for it to work, I have to compose a car type object. My object, say my car, equal to new car and return my car. Okay, now this method will work. However, I have to change its name because its signature same as previous. So let's see about signatures as well. Okay, so there is an inconsistent accessibility. So this method is public, however, this class is private. Therefore, the .NET is telling us that you have inconsistent accessibility. Either I have to make this public or I have to make this private. So let's make this private first. Now it works as expected. However, now I have to change its signature. So the signature of this method is integer and double. Does the order matter? Let's see. So if I make it double and integer, now it works because signature of this method is double and integer. This is also called as method overloading. Different signatures having same named methods, or let's say less differently. If you define methods same name but different features, it is called as method overloading.
Method overloading is the common way of implementing polymorphism. It is the ability to redefine a function in more than one form. A user can implement function overloading by defining two or more functions in a class sharing the same name. C# can distinguish the methods with different method signature, i.e. the methods can have the same name but with different parameters list, i.e. the number of the parameters, order of the parameters, and data types of the parameters within the same class. Overloaded methods are differentiated based on the number and type of the parameters passed as arguments to the method. You cannot define more than one method with the same name, order and the type of the arguments. It would be compiler error. The compiler does not consider the return type while differentiating the overloaded method, but you cannot declare two methods with the same signature and different return type. It will throw a compile time error. If both methods have the same parameter types but different return type, then it is not possible. Why do we need method overloading? If we need to do the same kind of the operation in different ways, i.e. for different inputs, in the example described below, we are doing the addition operation for different input. It is hard to find many different meaningful names for single action. Different ways of doing overloading methods. Method overloading can be done by changing the number of parameters in two methods, the data types of the parameters of methods, the order of the parameters of methods.
So let's make several examples of method overloading. I will start with adding a new class. Method overloading. I will make this class static. I will make it also public. So therefore I can access it from everywhere within my application. And then I will start writing. So the first method will take double x. It will return x plus x. Then the second one will take double x and int I. So it will return x and I, and it will return double as well. So I will write another one as integer. But you see, this time it will throw me an error because the return type doesn't matter. Okay. Also, you cannot directly sum double and integer. However, when I change it integer and integer, now it works, as you can see. So I can write another one like this, and now it can use integer I and double x. You see, it is still working because now the order is different and all have the same name. I can define so many different methods like this. This can also have something like this, or this can have like this. You see, with the same method name, you can define different methods. However, the key point is their signature. So the signature is double, okay. Signature is double plus integer. Then the signature is integer plus integer. Signature is integer plus double. So you see, the order matters, the parameter type matters, and nothing else matters. So the return type or accessibility level or the static or non-static doesn't matter. What matter is the input parameters and their order. I will write this link to here. Input types, input types, orders. Okay. So far what we have seen, let's note them internal. So the last accessibility level is internal. You can make it something like this. So there is also internal accessibility modifier. Internal means that you can access this method within this application, within this DLL. I can export my application as DLL, and then every method inside that DLL can access it.
The internal keyword is an access modifier for types and type members. We can declare a class as internal or its member as internal. Internal members are accessible only within files in the same assembly.dll. In other words, access is limited exclusively to classes defined within the current project assembly. Accessibility in same assembly, public, can be accessed by objects of the class, can be accessed by derived classes in other assembly, internal, cannot be accessed by object, cannot be accessed by derived classes.
These are the access levels. Identification here. Alright, so what else to show? The difference of static and non-static class. Okay, so let's say you want to return multiple parameters. Can we define a method something like this? Show you. Let's say public integer double string my awesome method. Can I write a method like this? No, you cannot return multiple elements from a method. So how can I solve this problem, solve this issue? How can I return multiple different types of objects from a method? There are several ways. Let me show you each one of them. Okay, let's comment this out. So let's say I want to return integer double and string from my method. What can I do? I can use tuple. So what is a tuple? Tuple means that tuple is a type that can hold different multiple types. So first solution is tuple. It is so easy to implement. So I want to return integer double, and this is kind of a list. However, it returns single object with the number of elements you have defined. So this can return new tuple. When I define new tuples, let's say integer double result, or let's say awesome. Okay, so when you define new tuple, you have to define it with like this. So this is a way of returning multiple different type of parameters. This is the first way, method.
C# tuple. The tuple less than t greater than class was introduced in .NET Framework 4.0. A tuple is a data structure that contains a sequence of elements of different data types. It can be used where you want to have a data structure to hold an object with properties, but you don't want to create a separate type for it.
Okay, so usually you can define a tuple with 7 objects, the rest. Okay, an example is here. So the rest also can get more items, but to access the rest items, you find it like this. There are also nested tuples. You see, for the rest, you can create another tuple like this and another tuple like this. So this is nested tuples. Okay, I will leave this as a description, and now let's see our tuple example. Okay, so how can I use this tuple? So let's make an example. Usage of tuple. Okay, I have dragged and dropped a list box, so it is now taking my entire space on my VPF window. Therefore, first I define an height like this. Okay, now it is more visible. Now I can resize it as I want. Okay, now add a button for tuple example. Tuple. Okay, I will copy and paste the examples here. When I double click the button, it composes the background click event of the button. You can also see the click event of the button on its XAML code here. You see it is defined like this. So the VPF runs with the VPF interface runs on XAML here, and there is also code behind. Okay, so first I will get a tuple of my awesome method. Return will be equal to my awesome method like this. Then I will access and add elements to my list box. How am I going to do that? Let's give a name to my list box first. You have to give a unique name to your interface objects first, then you can access them in the code behind. Okay, I will name it as listbox1 items add. So I will use auto format dollar. So let's say item 1 will be equal to my awesome tuple method return dot item. Then item 2 will be equal to item 2. Item 3 will be equal to item. Okay, let's run the application and see. So you can access the elements of tuple with like this. So you see there is no unique names. You have to access them as item 1, item 2, item 3. Therefore, I will say it is not that much useful, explanative. However, there can be useful scenarios for tuples. Okay, it is working. So let's write 8 or 9 items having a tuple. Okay, you see, it's showing me that this integer is the 7th element of the tuple. Then it becomes rest. So let's make this. So you see, it is giving me an error. Why? Because the rest can only be one item. Okay, therefore, after the rest, you cannot continue. So the rest can be like list integer. It can be like this. I will name this as like this and return new. It will automatically type me the return type like this. Then I can type my parameters. The first item string, let's say step1, then integer this, let's make it 101, double like this, string 2 like this, another integer, then another string 3, another integer, let's make it something like this, new list. Okay, and the list can be infinitely anything. List 1, list 3. Okay, so it will return this. Oh, this is the integer list. Now I can add my awesome tuple to this. So you get the idea of the T-rest. T-rest can only be one item, but it can be list, it can be another tuple, it can be anything you want. Okay, so item 1, item 2, item 3, like this. I can add item 4. You get the idea of tuple. I can add item 5. Oh, I have to change variable. I can access the item rest like this. Name it as T-rest. To use it, I will use T-rest index 2. And it will be item, or name it as rest. Since rest is list string, so you see it is showing me the rest. I will access the, okay, so it says that the last element of an 8 element tuple must be a tuple. So we cannot put a list as the 8th element. Therefore, I will move this list as 7th element, this, and I will make the last element any generic tuple, it says, like string, and of course this string integer double string integer, then another then list. Okay, and then we will need a tuple. When I say new, it doesn't complete, type this new tuple. Okay, now automatically it's two. Okay, now you should give also better names. I am just giving some random names right now. They are not very definitive. 7. Let's rerun the application. Tuples can be very useful, quick to write sometimes, but I would suggest you to use classes. So this is the first way of returning multiple different type of elements. The other way would be something like this. So I will write equivalent of this one like this. List object. So it will be simply list object. And now when you use list, the new keyword has to be starting with curly bracket. Now I can use this one, the tuple. You see, it is much more clear. However, now when you return it, you cannot know the returned types. What I mean is, for example, when I type like this, there is nothing. So what can I do? I can access it like this. However, now I don't know type of the first object. It is string. Therefore, what can I do is I can explicitly write the types. Okay, so it is string. The second one is integer. It can be double as well. Third item is double. Fourth item is okay. Then I will write the second element, the list, as it is a list, as you can see here. It is the 0, 1, 2, 3, 4, 5 index. You know that index of arrays starts from 0 in C#. Then I will access index like this. However, to be able to access it, so you see it becomes much complex here. Same rule will apply on this one as well. Okay, so this will be a tuple. This is a bad programming, but to be able to show you, I am doing it as an example, but this is a bad programming, believe me. This will be the, okay, we have some problem. Now you see, says that it cannot convert object. Oh, I know the reason. I know the reason because I have to define the index of the item, which is 7. Now you see we have written the both functionality in the different ways. Now they are both working, expecting. Now the third way would be defining a custom class, which would be my preferred way. The third and the proper way is defining a custom class with the desired parameters. So let's define a public class and the class name our great. And so which parameters we need? We need a string. For that I will use prop top. I will write it string first. So what is the difference between get and set having string? Okay, meanwhile this is being a property. This is just a field. And there is a difference between fields and properties. You can overload and change how the way properties works. However, the fields are just fields. Okay, so let's see about field and property difference. So I will write this custom property. Okay, and get will be for custom properties work. We have to keep a private variable like this, which will be only accessible within this class. Since this is private, it can be only accessed by the methods inside parent class, not from the parent of parent class. Only the direct parent class can access private elements inside that class. So let's name it as property this. So when it returns the name, it will append datetime in front of the name like this as our custom property. And when we set the name or the property, you see this is the get. Get means that whenever you access the property, it will call this method. This is actually a method. Okay. And this is also set. Whenever you set the property, it will be set like this. I can make it equal to value, or we can make an addition to the value such as to upper. Inside the upper, okay, let's make it just upper. Okay, and I will show you the difference of get and set methods. What else we need? We need an integer. I will make integer, first integer as field and the second as property. As for the field integer, int ir1, by default integer is 0, and by default string is null, null, by default 0, and then we have double. I will make the double as field 1. By default double is 0. Then we have the string 1 and string 2. String change this as first double. Second integer will be a property as well. Second integer, to keep it private. Okay, when we return the second integer, I will return 10% of the integer, and when I set it, I will set it as value plus 5. So you will understand the difference. There is third integer. So the third integer will be by the way, a default property. Integer third. So it will have the default get and set first list. It is a string first list. I have to initialize it like this. So it will be an empty list. When I initialize any instance of this class, this string list will be also initialized as empty list. So by default, the list will be null. And then finally a tuple we have. Public tuple, string, first tuple. Okay, I won't initialize, so it will be like this. I won't initialize this as well. I will let it by default null. So let's compose an instance of our class like this. I will name it this or let's say, or actually we can define a method and it can return custom this private class and type is grade class with nothing as parameters, and it will return new our grade class. So this will return a default instance of the grade class like this equal to return grade class. So let's see the default of grade class. I can use the var keyword as well. So the var keyword is being an instance of, you see, under namespace lecture 1, under main window class, it is our grade class. Okay, let's put a breakpoint here. Let's see the default values of our grade class. So by default, our class is null because classes are reference types. They actually have no value by default, therefore they are null. We will see about reference types and such in future. I move one step and now I can see the default value. So you see second integer. This is private, therefore I can only see it in debug mode, but I cannot access it from anywhere. It can be only accessed within inside of this class. Okay, so these are the private values. You see 0 and null. Then first double 0, first integer 0, first list null, it's a list. First by default it is null. These are the properties you can see. So the custom property, it is by default a datetime. When we read it, even though our value is null, first null, second null, third integer 0. Now I will initialize my values. So how can I do that? I can do that like this. You see first double with semicolon, I can define it something like this, equal to first integer will be 99 and first list will be new. I have to use new. Initialize list as grade 1, 2, C, and then first tuple equal to new tuple 1, 2, and then what else we have? Second integer 1000, custom property as named as programming, and then we have first cool, then we have string second, and then we have the third integer as like this. You see now I can give hence making names to my variables like first double, first integer, first list, whatever. They are not item 1, item 2, item 3, or like here without anything. So when you define a custom class, the best way, and now I can add it to my list box to show you how much better it will be, much easier, better, and readable. When you write a code, your code has to be readable. It is extremely important. Let's start. Our first variable will be, let's say, second. You see, I can put any variable with the name itself. So I will type this as second integer. Then I will put top character or let's comma. Then another item will be, let's say, first list. So first list, second item, so index 1 equal to this, the second item. You can say also like first. Okay, by the way, if your list doesn't have two items, then this code would throw an error in the runtime. Can we prevent it? Yes, we can prevent it with list overloading. However, it is a more complex thing. So I don't know if there is a null check this. Yeah, let's try it. I wonder if it will work. So we don't have 11 items. Therefore, if this null check works, it will not throw an error. Oh, it's throwing an error. So this null check is not working. Okay, let's try like this. Yes, it is null. Nice. So it didn't throw an error. Therefore, with this way, by default, it will be null because it is string list. So let's compose an integer list. Name it as second. Okay, now let's initialize the string list, a new list. These are still zero based index. Then list. Now we will see the difference of default values of string and integer. Okay, so the second object of the first list is empty. 11th object of the first list, I mean the second object of the first list is grade list 2. Let's see it if it's true. Yes, grade list 2. We can see it here. This is the second object. 11th object of the first list is nothing because when you convert null into string, it becomes nothing. Empty character. Then the second object of the first list, a second list is 12356. We see it's true. And the 11th object is 0 because the default value of an integer is 0. Meanwhile, the default value of the string is null. Okay, it is working as expected. Now let's see our modified custom property. To test it, change another line into our list. So the custom property is programming. We set custom property string expected, or let's say given value, or let's say set value is programming, and let's see the output of the reading. So when we read it, what do we expect? We have set programming as value. And when we check our code, we will see that when we read it, it will return the set value plus date time now. And when we set the value, it will convert it into uppercase. So we will see date time plus character plus uppercase of programming. Let's see, this is the way. Okay, custom property string set value is programming and returned value is you see date time, empty character and uppercase of programming. So this is what is about having properties with custom get and set method. Okay, overriding basically the get method, we are overriding the set method. You may not understand this right now, but over the time you will understand it. The same rule applies for integer. So let's see the integer as well. For the integer, we did set our second integer. Yes, set value of the second integer is 1000, and let's see the output value. So when we set 1000, it will be set as 1000 plus 5. And when we get it, it will return 5 because the 10%, actually this is not the percent we take. Okay, this is modulus operator or reminder operator. Yeah, this is the correct naming, reminder or modulus operator. So we will get 5, and I will also check the values from debug window so you will understand better. Okay, let's see screen. I run it. Okay, so you see the custom property in second integer set value is 5, however displayed value is 5 as we guessed it. Let's see from debug. When I hover my mouse, my cursor over my class is, so you see the private value is 1005, however read value is 5 because when we are reading, we are applying the remaining operator 10. When you divide 1005 to 10, the remaining value is 5. It is same for custom property. The value is programming. However, when we read it, it is date time plus programming.
Differences, uses, when and why. A field is a variable that is declared directly in a class or struct. A class or struct may have instance fields or static fields or both. Generally, you should use fields only for variables that have private or protected accessibility. Data that your class exposes to client code should be provided through methods, properties, and indexers. By using these constructs for indirect access to internal fields, you can guard against invalid input values. A property is a member that provides a flexible mechanism to read, write, or compute the value of a private field. Properties can be used as if they are public data members, but they are actually special methods called accessors. This enables data to be accessed easily and still helps promote the safety and flexibility of method. Properties enable a class to expose a public way of getting and setting values, while hiding implementation or verification code. A getProperty accessor is used to return the property value, and a setAccessor is used to assign a new value.
So you see, this is a very good answer. So it says that properties we can have value checking. What does that mean is, let me show you. Let's assume that you have a volume control of an application, a volume, name it IR volume. So a volume can be between 0 and 100, right? So what we are going to do is, we will do like this. We will assign value to volume, and then if volume is greater than 100, I will return 100. If volume is lesser than 0, I will return 0, else I will return volume. So you see, now I am having a control at the get method. I could do this in the set method as well. However, both works. So let's print some volumes. Okay, example, first I will set it to volume as this, then I will set it to 5, then this, then, so you will see the difference of set and get be equal to. So what values do we expect to see? Okay, let's run the application. What values do we expect to see? This is something hard to guess, I would say. So first we will see 0, the value will be set privately, minus 321. This one will show 55, the value will be set as 55. This one will show 100, the value will be 1554. This will show 0, however the value will be minus 1154. Okay, so here the private value will be different. So let's see 0, 55, 100 and 0. And let's see the private values of the last example or each example. Let's see private value 1, private value 5, value 4, and the private value will be this. Okay, so that because when it is going to do an addition, it will read its current value, and when you read the current value, it will be read as 100. Okay, because it cannot access the private value at all. Okay, so the private value is, you see, minus 321. The private value is 5. Okay, the private value is 1554. And now the private value is 1154. Why? Because when it is going to do an addition, it will read the value, and when it reads the value, it returns 100, not 1500. Okay, so this is about fields and properties, classes, instance having objects. Since this was an instance-based class, we define an instance of that class, and then we can set values. For example, I can compose another class. My grade class 2 will be initialized like this. I can set volume as 24, and then can write the volume of total volume plus this. So what would be the total volume in this case? This is initializing another because we are using the new keyword here. The new keyword is important because it creates a new instance. Okay, it is used for initialization of objects, a new instance of objects. All right, so what would be the output? In this case, the output will be, in this case, the first volume will be 0, the second volume will be 24, therefore the total volume will be 24. We will be able to analyze each instance unique values. As you do programming, you will understand the concept of instances and static variables. Okay, so you see the total volume is 0, 24. Do you know why? Because inside listbox, it has converted these into the strings, then printed them. Okay. And the second case will be like this. Output is 0, 024. Output will be. So you see the importance of parentheses when working with C#. In this case, here, first .NET compiler convert this into a string, then do string concatenation. Okay. But here it will do a mathematical sum, then it will convert it into a string. Okay. So basically this is equal to, first way is equal to below way. This one is equal to string. Okay, so you see this is same as this one. Let's run the application. Okay, 024, 24 and 020. Okay, let's dock this. Alright, so for the first day, first lecture. Okay, I think at the home you should make some other examples of what we have seen so far. like method overloading, void return type, custom class return type, tuple return type, private, public, static instance of members, static methods, and such. When working at home, do not just copy and paste my code. Try to type it yourself. It will help you tremendously, believe me.